Okay, so the last thing that we have to talk about in section 6.2 is the difference between finding normal probabilities and finding inverse normal values. So what we have done so far, every example that we have done where we've been finding probabilities, we've been using our table and or StatCrunch to actually find a percentage or a probability. What we're going to do in this very last section is we're going to reverse our process. So looking at what we have here, we can be asked one of two types of questions in this section. Right? The first type, what we have done so far, is finding our normal probabilities. We're given a value. We're given a height, a length, a score, or something along those lines, and we're asked about a probability that goes along with it. Now what we're going to do for these last few problems is we're going to go in reverse. Instead of being asked to find a probability, we are given a probability. Once we have that probability or percentage, then we're asked to go backwards and find a value. Kind of similar to some of the different things that we did in chapter 3. We talked about the difference in some problems between going forwards and going backwards, so it's kind of the same idea here. Before we get into problems actually finding the probabilities and or values that we're looking at, in this next example we're just going to compare the two different types of problems that we could be asked. So in this example, suppose the amount of money people keep in their online PayPal account follows a normal model. For each situation, identify whether the question asks for a measurement or a normal probability. So in example A, a PayPal employee wonders what the probability is that a randomly selected customer will have less than $150 in his or her account. Right, so looking at this one, we are asked for a probability. Right? What is our probability? This is just like the problems that we have done so far. So if we were given a mean and we were given a standard deviation, we could draw a sketch and find our probability just like we did in every example previously in this section. So this is an example of finding normal probabilities. Right? We are given a value and we are asked to find a probability. Now for B, a PayPal customer wonders how much money he would have to put in the account to be in the 90th percentile. Right? So now we are looking for a value. Right? We are looking for how much money. We are actually given a probability or a percent. Right? So we're given a percent, in this case 90%. So this would be a case where we are looking at finding inverse normal values. Right? So the difference is, are we being asked to find a probability or are we being asked to find a value? Again, the first half of section 6.2 right, is all finding probabilities. Right? The second half or second portion that we're going to look at today, we're going to focus more on our finding our normal values. We'll do a couple of examples where we're going to be going back and forth. So we might end up doing a little bit with our normal probabilities as we did in the previous part of section 6.2, but we're going to focus more on this second case here. Okay. All right, so our steps. Our first step is going to be exactly the same as it was to find our probabilities. Our first step, whenever we're dealing with anything in section 6.2, we always want to draw ourselves a picture. So we want to sketch the normal curve, we want to label it, and then we want to shade in the region of interest. Then we're going to find our z-score. In this case, instead of finding a z-score from a formula, we're going to find our z-score from a percentile. A percentile is a percentage that we're looking at. And so we're actually going to find the z-score from our percentile using our table. So instead of using a formula to find our z-score, we're going to use a table to find our z-score. Once we have that z-score, we're going to use another formula similar to one that we saw in chapter 3 to reverse our z-score formula and actually find a value in question. So what we're going to do is we're going to take our mean that we're given, and then we're going to take our z-score that we get from our table times our standard deviation, and then combine those to give us our value that we are looking for. So again, we are not finding our z-score using a formula, we are finding a z-score using the table. Once we have that, then we are going to find the value in question. All right, so in example 10, We're using the same normal model that we used in the last couple of examples for finding our normal probabilities. So this is going to be labeled the same way. So it's a normal model with a mean of 500 and a standard deviation of 100. So again, we find our values by adding or subtracting our standard deviation going in each direction. Again, this one, just kind of sticking with the same example because they're nice, easy numbers for us to use. A scholarship is awarded to a student who scores at the 96th percentile or above. What is that score? So here we are given a percent and we are asked to find a value. We are asked to find a score. So the first thing we want to do is we want to draw a sketch. So unlike last time where we were drawing sketches based on exact values, we're going to draw sketches kind of more based on approximations. So if we think about 96th percentile, well, the 96th percentile, right, is going to be towards the very top. So if we found our 96th percentile, right, it's going to be somewhere over here on the right. So what we have here and what we're thinking about is in this shaded area here, this shaded area represents 96%. So the larger the percentile that we're looking at, the more shaded area we are going to have. Again, it's not going to be quite as precise as some of our pictures in the previous section, but we can go ahead and draw a sketch to give ourselves an idea of what type of area we're looking at. Are we looking at a large percentage, a large area? Are we looking at a small percentage or a small area? And then what we're going to do is we're going to use our table to find something as close to this 96% as possible. Right, so what I have underneath here is actually a smaller version of our standard normal probability table. And what we're going to do, instead of using our heading for in these columns and then up above along the top, we're not going to be using our z-scores. That's what we're looking to find. We're going to be focusing on the values that are in the center here in our table. So if we look at this table, right, we want to find the number that we can get as close to 96% as possible. 96% is 0.96. So if we look at these values in our table, this number that I have circled, this 0.9599, is as close as we can get to 96%. It's not perfect, but it's close enough. If we look at the one number to the right, 0.9608, it's close, but this one here that we have circled is actually a little bit closer. Right? So instead of finding stuff using our labeling along the far left column and then the row on the top labeling all the columns, again, if we're doing these types of inverse normal problems, we're actually going to be looking at the data in the middle of our table. All right, so we found as close as we can get to 96%. Now, if we back out a little bit, notice that I have arrows drawn to a couple of different values. So going to the left, right, this is in the row that corresponds to 1.7 for our z-score. And if we go up, it's corresponding to the column that has the 0.05. So what this means is that our z-score that we're looking at for this particular problem, starting with what's on the left over here, we have 1.7. And then if we use our second decimal from up top, we get a 5. So again, this z-score is not coming from a formula. This z-score is coming from the numbers in the center of our table. Once we have this z-score, then we're going to convert this z-score to our units. So in this case, our x is going to be, remember mu is our mean is 500, plus our z that we just found is 1.75, times our standard deviation, which is 100. According to order of operations, we multiply and then add. Again, you can do it as one step in your calculator. We can work it out into two. If we do it in two steps, 1.75 times 100 is 175. 500 plus 175 is 675. All right. So that means the 96th percentile score is about 675. We use the word about or approximately in a lot of the problems going either direction in the section because it's not exact, right? And again, we're thinking it's a model, so it's not necessarily a perfect representation of our data, but it should be relatively close. So the 96th percentile score is about 675. So now we're going to work through another example. We're using the same model as above. So again, I'm going to label my standard normal curve using my mean and standard deviation. Again, we kept this one nice and simple so that way we have easy numbers to work with. Right. A scholarship is awarded to a student who scores in the 90th percentile or above. So 90% is still a pretty large area. It's not going to be quite as large as what we shaded in up top there, but we're still going to shade in a pretty large area down here. Again, these pictures, these sketches aren't going to be perfect when we're dealing with percentiles, but they should give us kind of an idea of what we're looking at as we're going through these problems. Okay. Right, so now we're asked to find our z-score. So what we're looking for here is we're looking for as close as we can get to 90% as possible. Right. So it's actually in this table, but just to make it a little bit easier to see, I'm going to grab my printed copy of my standard normal table. Remember when we're looking at our table one side, we have negative z-scores. When we're doing with these negative z-scores, our values are going to go up to 1/2. We're only going up to 50%. Anything more than 50% is going to be on the positive side of our z-scores. So on the positive side of our z-scores, we have these different values. So we want to find something as close as we can get to 90%. So looking at our numbers, 90% would be 0.90. So looking through here, we have stuff in the 70s, 80s. Here we get into the 90s. This 0.8997 is going to be as close as we can get to 90%. This value over here on the right is just a little bit too large, so we are going to use this one on the left. Right? So using this one on the left, if we go across this row here, right, we are in the green row that starts with 1.2, and then if we look up, we get 0.08. So our z-score is going to be 1.28 that we are going to get from our table. Right, now that we have this from our table, we're going to convert this to units. Right, so we are going to take 500 plus 1.28 times 100. Again, 500 is our mean, 1.28 is our z-score, 100 is our standard deviation. Right, we multiply 1.28 times 100 gives us 128. So x turns out to be 628. So the 90th percentile score is about 628. All right, working through example 11 on the next page. We are going to start, again, we're going to use the same normal model just because it's nice, easy numbers to work with. So we're going to start by labeling our picture. Our mean is 500, our standard deviation is 100. Right. Then looking at this, in this particular problem, we are asked to answer the following questions about the interquartile range of the distribution of scores. So interquartile range, again, bringing back some things that we talked about in chapter 3. Our interquartile range is between 25% and 75%. And remember, it's going to be the middle between those two values. So if we look at our z-score, right, our middle 50% should be right here around our mean. So this is what we're looking at and what we're thinking about as far as shading and going for this particular example. Right? So again, it's not necessarily going to be perfect, but we can hopefully get pretty close. Right? So we've sketched our curve. We're looking for the middle 50%. So now we're going to use our table, and notice that we have two z-scores that we're going to find. We're going to find our z-scores that correspond to 25%, and we're going to find our z-scores that correspond to 75%. All right, so our 25% is going to be on our negative side of our z-score table. Right, so we want to find something as close as we can possibly get to 0.25. So looking up here at the top, we have very, very small percentages. Now we're down to 1 or 2. We're getting into teens, about 20%. So as close as we can get to 0.25. Well, we have 0.2514 or 0.2483. Thinking about the difference between 0.2500 and these, this 0.2514 is just slightly closer to 25% than this one over here. All right, so we're going to use this value. Looking at our table, if we go to the left in this row, we are starting in the row that starts with z equals negative 0.6. And then if we go up just slightly, notice that our second decimal value is 7. So for our 25th percentile, the closest we can get, z is negative 0.67. All right, to find our 75th percentile, we're going to use the positive values that are on the back of this table. So we start at 50%, right, and if we look, we kind of go quickly. We're at 70%, here 76, a little too much. If we go back here, 75% is going to be somewhere right between these two values, because 75% would be 0.7500. This number is slightly closer to 75%. This corresponds to a z-score of, moving to the right, 0.6 and up 0.7. So our z-score for this is going to be positive 0.67. It shouldn't be a big shock that these are the positives and negatives of the same number, because each of these are 25% away from our mean. Right, so each of these should be equally spaced out to the right and left from our mean. Again, both of these values are coming from our table. All right, now we want to find our specific SAT scores that give us these boundaries. So we're going to take our 500, which is our mean, and then we're going to take our z, negative 0.67 times 100. If we multiply this out, 0.67 negative times 100 is going to give us a negative 67. So 500 minus 67 is going to give us 433. And then our other formula is going to look very similar. We're just going to have a positive 0.67 instead. So we get 500 plus 67, which gives us 567. All right, our interquartile range, remember, is Q3 minus Q1. Q3 is our 75%, the value that's associated with 75%. Q1 is the value that's associated with 25%. So we're going to take 567 minus 433 to give us 134. Now we're going to compare this interquartile range to one standard deviation. Right, so our interquartile range we just found was 134 points. Right? So our interquartile range is 134 points. Right? One standard deviation. One standard deviation, our standard deviation is 100. Right? So one standard deviation is 100 points. So if we compare these two numbers, right, our interquartile range, 134 points, is slightly larger than our 100 points. So we're going to say it's larger because 134 is more than 100. Another way to think about it, going back up to our z-scores, were negative 0.67 both above and below, which gives us a difference of 1.34 standard deviations total for this middle 50%, which is also larger than one standard deviation. Easiest way to think about it, though, more than likely just to compare these two different values, right? Which one is going to be larger? Right, we can also find these values using StatCrunch, just like we did when we were finding our normal probabilities. So StatCrunch has an ability to work with us both in our forwards finding normal probabilities problem and our backwards problems, where we're looking for finding the inverse normal values. We start off the exact same way. Right, we're going to go to stats, we're going to go to calculator, we're going to select the normal. Again, all of this in chapter 6, section 6.2, we're dealing with our normal calculator. We're still going to enter our mean and our standard deviation. Right? So as far as these go, we're going to not necessarily worry about the between ones. We're going to think about these standard ones. And then from there, again, we can select to make sure that it's labeled appropriately. And the difference is what values we're actually going to plug in. Right? So we're not going to enter a value in our parentheses there. We're actually going to enter a percentage in our problem. So this is what the screen gives us in StatCrunch after we enter everything in. So in this case, we're going to go back to example 10 that we did a couple of pages ago in the notes. And we were asked to find the 96th percentile. Right? So what we entered into StatCrunch, we entered our mean, we entered our standard deviation, and then we actually enter our percent as a decimal, this 0.96. And then when we compute, it gives us this value here in these parentheses. This 6.75.06861, which if we round this off, this rounds off to about 675. Right? That matches example 10 when we worked it out. We said that our 96th percentile score was about 675. All right, so these last couple of examples, we're going to look a little bit more at our normal probabilities and our inverse normal values. Right, so let's start with this first part here at the top. According to the National Health Center, the heights of 6-year-old girls are normally distributed with a mean of 45 inches and a standard deviation of 2 inches. First thing we're going to do, it doesn't matter what type of problem we're talking about, we're going to label our curve. So our mean is 45. Right? Then using our standard deviation, we're going to add 2 going to the right. We're going to go back to 45, subtract 2 going to the left. And example A says, in which percentile is a 6-year-old girl who is 46.5 inches tall? So in this case, we're asked for a percent. Since we're asked for a percent, this is a normal probability problem. Right? We're going to use StatCrunch to determine the probability. So in our picture, we're going to find 46.5 inches tall. Right? And percentiles, we always shade to the left. If you look at all the previous examples that we've done, we've shaded to the left. So we're going to shade this area to the left here. Right, then working through this, we can use StatCrunch. We're going to enter a value for our mean. Our mean is 45. Our standard deviation in this case was 2. Again, if you click on the tick marks button up at the top, if it's not already selected, that will give you a curve that's going to match ours labeling wise. Then we put in our less than, because we're thinking about a less than probability because it's a percentile. And we're going to put this 46.5 in here. So that's what we're going to enter. And then what we're going to get out, 0.77337265, which is about, and it rounds to about 77%. So in example A, we are asked to find a probability. We are asked to find a percent. Right? This is one of our forwards problems from the first half of section 6.2. This last problem then down here at the bottom. If a 6-year-old girl who is 46.5 inches tall grows up to be a woman at the same percentile of height, what height will she be? Assume women are normally distributed, right, as n 64, 2.5, So what we have here is a slightly different normal distribution. So our mean is 64. And then as we move to the left and right, we're going to add or subtract 2.5. So we add 2.5, we get 66.5. We add 2.5 again, we get 69. We add 2.5 again, we get 71.5. Go back to 64, subtract 2.5, gives us 61.5. Subtract 2.5 again, gives us an even 59. Subtract 2.5 again, gives us 56.5. Now in this case, we're not asked to find a percentile, we're asked to find a height. What height will she be? Okay. So what we're going to do is we're actually going to use our answer from example A to find our height for example B. Okay. So if we look at this, we're going to draw our picture with about 77% shaded in. Since we are starting with a percent and looking for a value, this is an inverse normal problem. Right? In this case, we are looking for a value. More specifically, in our case, we are looking for height. Right, so in StatCrunch, we're going to enter our mean, which in this case, remember we changed to 64. Our standard deviation in this case is 2.5. Right, we're going to leave this first part empty, and we're going to plug in 0.77 on that other side before we hit compute. And this is going to give us a value of 65.84717. That's going to give us a value of about 66 inches tall. So the key thing as you're going through section 6.2 is you're going to want to be asking yourself, am I looking for a probability, am I looking for a percentage, or am I looking for a value? Right, if you're looking for a probability, it's like the first half of the chapter. Right, first half of this section, we're going through and working through our problem that way. And then in the second half, we are looking for percentiles. So we are working backwards, and our final answer that we're starting with that percentile, then we're given a value to end up with.